Hello everyone, we are the team N1 and today we are going to present you our second assignment from the Data Management and Business Analytics course.
In the context of the appearance of a new influenza in the United States that affects kids more than adults, our team of consultants was chosen by the American Task Force to do a study in order to know to whom are we supposed to send an invitation and to get the vaccine and to maximize the effects of this vaccination campaign. To do so, we need to create a predictive model to predict which parent is willing to accept these invitations to get their child vaccinated. The construction of our model is going to be based on some data that we get from a random selection among kids from a similar and previous campaign which was about H1N1. Since the marketing campaign is very costly, we need to minimize the number of invitations and at the same time maximize the impact. To do so, we must select the right variables in our database in order to target the group of people who are the most likely to accept the invitation.
Based on the available data on children invited to get vaccinated against the H1N1, we decided to look at the number of people who accepted vaccination against this influenza. The study found that only 4,500 participants out of 12,700 chose to receive the vaccine. This study therefore shows that the vaccine invitation process used by the state is inefficient because marketing and logistic costs don't correlate with vaccination rates. For this reason, we decided to study in more detail the characteristics of families who were not reluctant to vaccinate their children against H1N1. In order to identify and analyze the specifics that might influence participants' decision-making. We first investigated whether there was a correlation between having previously received the seasonal flu vaccine and the decision to get the H1N1 vaccine. We found directly that 73% of parents who decided to vaccinate their children against H1N1 had already vaccinated their children against seasonal influenza at least once in the 12 months prior to the interview. Then we decided to look at whether there was a link between the wealth of families and their reluctance to have their children vaccinated. We saw that families who were above the poverty line were less likely to refuse the H1N1 vaccine. We can see that among those who took the H1N1 vaccine, 80% came from a family above the poverty line. Based on our research, we therefore advised the government to start sending vaccination invitations to families who have already vaccinated their children against the seasonal influenza. In addition, the government should target families who are above poverty. This will optimize and accelerate the process of inviting vaccination because these families are not unwilling to have their children vaccinated.
For the modeling part, so in order to create our predictive model, we used the two database in our presentation. The model is based on different variables that we found relevant and that will allow us to know to whom to send an invitation to come and be vaccinated. After exporting the database from the training sheet, we split our model in two parts with the multiply operator. In the first part, we clean up our data and determine which attribute to select. After this, we added the one-hot encoding operator in order to develop a matrix correlation. For the second part, we repeated the first two attribute selection step as done previously. Then we used the generate attribute operator to make the variable PUTD 1 and 1 binary in order to continue our model. The variable PUTD #1 and 1 take the value of 1 when the participants respond positively to the invitation to be vaccinated against #1 and 1, otherwise 0 when he declined the proposal. After we reused the one-hot encoding operator and changed the selected numeric attribute to a polynomial type. In the next steps, we defined the role of the variable PUTD -1 and 1 as being the label since this is our target variable. We also divided the dataset into partitions with the help of the split data operator. To estimate the statistical performance of the model, the cross-validation operator was used. And finally, in the last step, we imported the blind data nullable sheet. Then we added the one-hot encoding operator, then changed all the numerical variable to a polynomial variable so that we could apply them in our model. Secondly, in order to group the two database, we used the apply model operator. And finally, we also chose the relevant attribute in order to put our model in application of prediction of model of prediction application.
In order to measure the performance of our machine learning model, it is essential to perform a performance analysis to make sure that it will also work with any database. Therefore, using the confusion matrix, we were able to observe how often the predictions of our model are accurate to reality in our classification problem. As we can see, the accuracy of our model has a high percentage, which is 65.10%. As a result, our predictions tend to reflect reality. Then we have the kappa, which measures 0.164. That means that the amount of accuracy is 16.4%, and so it's a weak amount of explanation of the model. But the quality of the coefficient depends on several factors, such as units of measures of the variable, the unit of the variable employed, and the applied data transformation as well. Thanks to the accuracy, we can calculate the classification error, which is 1 minus 64.10%. And the result is equal to 34.9%, which is a good result because it means that we are only wrong about 34.9%. In addition, we can explain the accuracy of our model in several ways. First, the true positive, which is equal to 5,525. This represents the number of people who were predicted to respond to the invitation and did respond. Second, false positive, which is equal to 2,535. This represents the number of people who were predicted to respond to the invitation but did not. Third, false negative, which is equal to 1,026. This represents the number of people who were predicted not to respond to the invitation, but who, contrary to what we predicted, did respond. And fourth, true negative, 1,116. This represents the number of people who were predicted not to respond in the invitation and who did not respond.
According to our prediction, among the 4,251 persons in the file, 25 of those people will accept the invitation to send their child to get vaccinated, while 76 will refuse it. Among the 1,000 children who will accept the vaccine, according to our confidence interval, the model predicts well in 53% of the case. So we can say that we are confident that 578 will respond positively to the invitation. On the other hand, among the 3,180 who will refuse the invitation, the model predicts well between 51 and 81% of the case, which means that we are confident that between 886 and 1,357 of them will refuse the vaccine. Our goal is to maximize the impact of the vaccination campaign, so we suggest sending invitation only to the 578 children who are more likely to accept the invitation and get vaccine. We can also suggest to send invitation to the other person that we predict that they will accept the invitation, but we are not sure about it. Finally, we believe that those who have already get their seasonal vaccine are the most likely to accept the vaccine against the new influenza. So, we advise the American task force is to start by inviting those kids.